Welcome back. Today we're going to talk about angles and their measures. And the kind of driving question behind this first part is how do we measure direction? Or, when we start to look at triangles and we start to look at applications, we're going to be going in certain directions. And to figure out how long a distance is or how far I have to travel, we use direction. We use angles to see, in a triangle, how long is the hypotenuse? Well, from the base, I open up a certain direction, a certain angle, and it tells me how much I'd have to open up to get to the other side. And so as we look at all this, we need to understand some of the basics. And this video is about the basics of degrees and minutes and seconds and how they all work together. So let's go. This here, this first symbol here in this first box is degrees. And I use this, so this would be like, for example, 3 degrees or whatever. And the definition of a degree is 1/180th of a straight angle. Think about that. You got a straight line. It's a straight angle, so 1/180th of that is a degree. When we look over here, this ties together very nicely with this DMS, which stands for degrees, minutes, seconds. And that's where the DMS comes from. Well, the degree is the same. So degrees, this is the same over here. So degrees is still 1/180th, but minutes we need to talk about a little bit. So I'm going to divide this into 3 columns with those not very straight lines, but that's okay. The degrees, that's that 1/180th of a straight angle, and that's my symbol for angle. Minutes, because we don't always have a whole degree, there are 60 minutes in 1 degree. Well, how do we write that? Well, that would be 60 minutes equals 60 with just one, it looks like an apostrophe, but it's 1 tick mark up there. You can probably guess what the seconds look like. There are 60 seconds in 1 minute. And so 60 seconds equals 60, and that's got 2 tick marks with it. Those kind of ran together. Let me clarify that. So that's 2 tick marks there for 60 seconds. Well, what does that mean? Well, that means in 1 degree there are 60 minutes, or 60 seconds per each one of those 60 minutes, or 3,600 seconds. Okay, so that's how the conversion works. We're going to convert here in just a second. So what are they going to ask us to do? They're going to ask us to convert to degrees, minutes, and seconds. Well, this is 37.425 degrees, 2 degrees, minutes, seconds. So this is already in degrees, so that's 37 degrees. And what I want to do is I'm going to convert this to minutes and seconds. So how do I do that? Well, I'm going to do 0.425. And so far that's part of a degree. Well, what part? I'm going to multiply that by, and if this is degrees, on the bottom of my bridge, I think you've done this maybe in physics before. If you haven't, this might be new to you. But if I've got degrees up here, I've got to put degrees down here. So 1 degree equals 60, and we're going to go to minutes first. So my units here would cancel. And so if I do 0.425 times 60, that's going to be 25.5 minutes. Well, what does that mean? In terms of my answer, I've already got DMS, so I'm going to put my minutes in red. So I'm going to take the whole part, so it's 25 minutes. And then I need to convert my seconds part. Well, I've used this, so now I'm going to do 0.5 times, well, if that's half of a minute, so this is 25.5 minutes, half of a minute in each, so this is minutes. So on bottom goes minutes, 60 minutes, 1 minute equals 60 seconds because I'm converting to seconds. And so these cancel. And so 0.5 times 60 would be 30 seconds. Things are skipping together here. 30 seconds. And so this here goes 30 seconds. Well, what's my answer? Convert 37.425 degrees to degrees, minutes, seconds. It would be 37 degrees, 25 minutes, and 30 seconds. Okay, that's how that little piece works there. Conversely, we're going to go the opposite way. So now I've got 42 degrees, 24 minutes, 36 seconds. Well, this is already out. So if I'm going to degrees, then I'm going to have 42 point something degrees, and I'm going to have to convert this here. Well, 24 minutes, my conversion here. There are 60 minutes in 1 degree. So if I multiply that, I'm going to end up with that piece. And so, because it's all going to be 1 decimal. So like all of this is going to be this plus my, so I've got this big multiplication here. So 24 over 60. So this is 24 over 60 plus, and then I need to convert my degrees or my seconds to degrees. And if I look up here, remember I've got 3,600 seconds are 1 degree. So I can multiply this 36 seconds times 3,600 seconds. And again, they're across from each other, so these units are going to cancel out in 1 degree. So what goes into my answer? So I've got 42 plus 24 over 60 plus 36 over 3,600, and I'd have to put those in parentheses in my calculator to get it okay. And that's going to leave me with 42.41 degrees. So I converted each individual, the minutes and the seconds, into degrees. Okay, so that's how I convert. That's one way to measure angles. Radians are another way to measure angles, and we're going to talk extensively about this when we start to talk about trig. But when we start to talk about radians, it's important to know this. Essential angle and I'm going to call it theta, and that's a 0 with a slash across it, has a measure, and of note, this theta, that's what we're going to use as an unknown angle. So like x is what we use for an unknown value, theta is what we use for an unknown angle, has a measure of 1 radian, which we would write 1 rad, that's the abbreviation for radian, if it intercepts an arc equal to the length of the radius. What in the world does that mean? Well, we have to have a central angle. What does that mean? It's an angle that extends from the center of the circle. And we're going to call this angle theta. So this is some unknown angle. We don't know how much it opens up until we evaluate, obviously the angle, we measure it. But what we're saying in here is, if this is a central angle, this is a radius here, and this is a radius here, right? If this opens up, so it opens up, and this arc here that I'm scribbling on right now is equal to the radius. So if this part equals the radius, so if it's the same length, then theta equals 1 radian. So the angle opens up just enough to cut off an arc that's the same length as the radius. So what does this mean? If I went all the way around, 180 degrees would be equal to pi radians. Why? Well, because basically if I took all of this and I cut off 180 degrees, so half of a circle, this big green one, what's the length here? This is half of the circumference. Well, if the radius was 1, let's say the radius is 1, then the circumference would be 2 pi, because it'd be 2 pi times the radius. So 180 degrees would be halfway around. So instead of being 2 pi, it would be pi. So 180 equals pi radians. And this is helpful because to convert, which we're going to have to do a lot, to convert to radians, multiply theta by pi over 180. This is a conversion factor because 180 equals pi. And to convert to degrees, multiply by 180 over pi, because this is degrees over, pi radians. The key is put what you want on top. So if I want degrees, I put 180 on top. If I want radians, I put pi on top. So let's do a couple of conversions. And I'll actually leave this conversion here. If I want to take it 2 radians, I know I'm going to take my 90, that's my theta, multiply theta by, and I'm going to multiply by what I want radians. So I'm going to put pi on top. And my 90 and my 180, this goes to 1, this goes to 2, so this would be equal to pi over 2 radians. That's as simple as it is, guys. And if I'm going 2 degrees, I'm going to take my pi over 3, helps to write it instead of a slash as a fraction here, I think. I'm going to multiply by 180 over pi. My pi's cancel, this cancels, and 180 divided by 3 is equal to 60 degrees. That's all there is to it, guys. Okay, so that's converting between degrees and radians, another way to measure angles. So let's talk here for a minute. Circular arc length. We're measuring arc length. So arc length is equal to S. That's the variable that we use for arc length. And if it's no units, so theta in radians, okay, because theta in radians is the default, so it would say like if theta is equal to 2, that would be 2 radians, not 2 degrees. So unless it's specifically outlined as degrees, it's got to be radians. So S equals radius times theta. That's arc length. So arc length equals radius times whatever theta is. In degrees, we're going to start out, it's going to be the same thing. So S is equal to radius times theta, but because it's in degrees, we have to multiply by our conversion factor. So this is going to be times pi over 180. So basically it would be saying, hey, I've got this angle here, but to convert that to degrees, I have to multiply by pi over 180. So we just kind of combine it all into one. What are they going to ask me to do with this? Pizza. They're going to ask me to find the length of crusts of pizza. And so how many inches of cheese in the crust of this stuffed crust pizza? That's saying, if I'm looking around the outside of this piece of this pizza, how much cheese is in there? Well, I need to give you a little bit of background information. This pizza has a radius of 7 inches or a diameter of 14 inches. It's a 14-inch stuffed crust pizza. And a slice is equal to 60 degrees of this pizza. So there will be 6 slices in this pizza. And so a slice is 60 degrees. So how much cheese, how many inches of cheese is that going to be? Well, because it's the outside, this is all an arc length, but I only want to know this one. So this is S, which is equal to my radius times theta. Well, what's my radius? What's my theta? My radius is 7 inches. And my theta is 60 degrees, but I got to convert to radians. So 60 degrees in radians would be 60 times pi over 180, because I'm multiplying by what I want on top. And this is going to be pi over 3. And so my arc length, my cheese, is equal to radius, which is pi over 3, times, my radius, which is 7 inches, times my theta, which is 7 inches. And I can leave this in terms of pi. So 7 pi over 3 inches of cheese. Or I could say that's about 7.3 inches of cheese. Okay, so if you're concerned about how much cheese you're getting in these stuffed crust pizzas, this is the problem for you. What about this? So I got these little piggies in a blanket around the outside. Looks like got a pretzel one up here. I don't know. But the question is, what is the radius of the pizza if a slice with a central angle of pi over 6 has a crust length of 6.5 inches? So I want the radius. And so I know I'm still talking about arc length here. So I'm going to start out with my formula. Radius times theta. And I know the central angle is pi over 6. And I know the crust length is 6.5 inches. What is that? That's this part. That's my S. So 6.5 equals, and I want my radius, so radius times pi over 6. This is just an equation that I'm setting up. And so if I go ahead and divide by pi over 6 on both sides, dividing by a fraction is the same as multiplying by the reciprocal, so 6 times 6.5 over pi equals radius. So that would be 6 times 6 would be 36, 6 times 0.5 would be 3, so 39 over pi equals radius, which is my answer. And I think my math lab is going to ask you to do that. They're going to ask you to do that in terms of pi. And so as you look at that, let me punch this into my calculator real quick. 39 divided by pi. That's about 12.41 inches for my radius. Okay, guys? That's all there is to it. We're going to cover the next part in class, but that is the basics of how do I deal with angles, how do I do some conversions with it, and a couple of word problems associated with it. So thanks for watching, and we'll see you next time.